Okay, let's just jump right into this explainer. For the longest time, working with artificial intelligence has felt, honestly, a bit like casting spells. You know the drill, you type some words into a chat box, cross your fingers, hit enter, and just kind of hope the output looks right. But if we're going to actually elevate our daily engineering practices, we absolutely have to strip away that mysticism. We need to replace this whole magic box myth with a rigorous, standardized engineering discipline. So today, we're going to get our hands dirty and look at the exact mechanics of prompt engineering. Now, this fundamental truth right here, it perfectly explains why an AI can write incredibly fluent, convincing code for an API that literally doesn't even exist. It's not actually lying to you. It's simply pattern matching. Large language models don't have some hidden magical database that they query to fact-check their statements. Instead, they just mathematically predict the most likely next piece of text based on their massive training data. Grasping this core shift, moving from looking up information to generating it token by token, is the foundation for absolutely everything we'll be covering today. So here is our roadmap for the session. We're going to start by aligning our AI mental model, then we'll break down the invisible math of tokens. After that, we'll explore your pattern arsenal, dive into the actual mechanics of tool use, and wrap up with prompt iteration and debugging. All right, let's kick things off with part one, the AI mental model. I want you to think of the AI as a brilliant, incredibly well-read new developer who just joined your team, but who totally lacks the crucial context of your specific internal systems. I mean, this new colleague has read virtually every piece of public documentation ever written, every single Stack Overflow thread, and every public GitHub repo. They're an absolute genius when it comes to general syntax and standard design patterns, but, and this is a massive but, they have absolutely zero idea how your specific internal API works. They have never actually run your codebase. And they can't natively verify if what they're telling you is currently true. You have to provide that highly specific context for them every single time. Let's move on to part two, the math of tokens. So the crucial takeaway here is that writing a short prompt doesn't necessarily mean you're actually passing the AI a short token count. You see, a token isn't exactly a one-to-one mapping with a word. It's roughly 3/4 of a word on average. When you hand the AI a document, it fundamentally chops it up into these little tokens. To put that into perspective, a typical 1,000-word document translates to roughly 1,300 tokens. And understanding this is vital, because tokens aren't just about system capacity. They are a strict, measurable quality metric. Basically, the fewer unnecessary tokens you feed the model, the higher the quality and focus of its generated output. Think about the math here for a second, because it brilliantly illustrates why casually pasting a 500-line code-base file into a prompt just bloats your context window incredibly fast. One word of standard English is just over 1 token, but a single line of C# code, wow, that can easily run you 10 to 20 tokens simply because of all the special characters, the brackets, the strict syntax. So if you just lazily drop an entire massive JSON file or a huge script into your prompt, when you really only needed to talk about 3 specific fields, well, you are flooding the model's working memory with a ton of useless noise. Now, 200,000. That's Claude's massive context window right now, representing the absolute maximum limit of working memory it could hold at any one time. And 200,000 tokens is massive, right? It feels like you could literally just dump a whole textbook in there and be totally fine. But here's the catch. Just because a model has this massive capacity doesn't mean it maintains perfect, razor-sharp focus across every single one of those tokens. You have to be aware of something called the lost middle problem. As your context grows, the model stretches too thin, and it systematically begins to forget crucial instructions that are buried right in the center of your prompt. Look, at 500 tokens, the AI has near-perfect retrieval accuracy. But by the time you hit around 50,000 tokens, the model is desperately trying to maintain 2.5 billion pairwise relationships between all those little chunks of text. Its attention capacity gets severely degraded. If your absolute most critical instruction is buried right in the middle of a massive prompt, there's a very good chance the AI will just ignore it entirely. The rule of thumb? Always put your most important constraints at the very beginning or the very end. Okay, on to part 3, the pattern arsenal. Mastering the foundational rules is what really sets the stage for our more advanced patterns. There are 10 core rules for reliable AI generation, and 3 of the absolute most vital ones are these. First, always lead with your intent. Don't bury it after 3 paragraphs of preamble. Second, use positive instructions. Tell the AI exactly what to do rather than just giving it a list of what not to do. And third, incredibly importantly, separate your concerns into clearly labeled sections. If you just dump a massive wall of text into the chat, the AI is going to really struggle to parse out your specific constraints from your general background context. These 7 patterns are essentially your day-to-day engineering toolkit, and they range from cheap, incredibly simple queries all the way up to complex, high-cost reasoning workflows. Think about it. You wouldn't use a sledgehammer to hang a small picture frame, right? In the same way, you shouldn't use a massive, token-heavy chain of thought reasoning prompt for a basic syntax check. You've got zero shot for quick answers, few shot for formatting, chain of thought for complex architecture debugging, role prompting to extract expert-level depth, and negative constraints to firmly lock down the scope of a refactor. Let's compare a couple. Notice how providing a few-shot example costs more tokens up front, but it acts as a rock-solid guarantee that the model will match your team's exact coding style. A zero-shot prompt is when you give the AI no examples at all. It's low cost, it's fast, and it's great for standard everyday tasks. But if you need the AI to format a JSON object exactly the way your finicky legacy system requires, that's when you use a few-shot pattern. You literally paste 1 or 2 perfect, ideal examples of the desired output directly into the prompt. Yes, it costs a few more tokens, but your reliability absolutely skyrockets. Actually, the absolute best engineers don't rely on just one pattern at a time. They stack them together to eliminate multiple failure modes all at once. Combining role prompting, few-shot examples, and negative constraints in a single prompt is an unbelievably powerful technique. The role prompting prevents shallow generic answers, the few-shot examples prevent the wrong data formatting, and the negative constraints prevent the AI from experiencing scope creep. And the best part? You aren't paying massively for stacking these. Each one just adds a handful of tokens, but the resulting output is drastically more robust and production-ready. All right, let's shift gears to part 4, the mechanics of tool use. So the crucial thing to understand here is that tool use is a heavy mechanical operation. It really should only be deployed when the AI absolutely needs to reach out and touch the real world. Tool use, or function calling as it's often known, is frequently misunderstood. We usually just think of AI as spitting out text or code. But with tool use, we're actually allowing the intelligence layer to interact with external databases, pull live APIs, or execute scripts. It's a real game changer for sure, but it is also significantly slower and more expensive. Picture this. The model is generating text, but then it actually pauses its generation, hands off data to your application harness, and patiently waits for the result to come back so it can continue. When an AI decides it needs to use a tool, it literally stops writing. It outputs a structured intent, essentially saying, hey, I need to call this specific function using these exact arguments. The AI cannot execute the code itself. Your application, the harness, actually runs the tool, grabs that real-world data, and feeds the result back into the model's context window. Then, and only then, can it finish its answer. It's a multi-step loop, and that right there is exactly why it adds so much latency. Finally, let's wrap up with part 5, prompt iteration and debugging. This is absolutely crucial. Every single hallucination or missed requirement has a specific diagnosable cause. It's not magic failing, it's just a bug. If the AI's output is way too generic, well, you didn't give it enough specific context. If it's the wrong shape or format, you're missing an output specification, like a few-shot example. If the AI went rogue and changed code it wasn't supposed to touch, you lacked negative constraints. And if the advice it's giving you is just shallow and obvious, you need to add role prompting to force it into an expert persona. Please stop randomly rewriting your prompts out of pure frustration. This DA workflow, diagnosing and adding just one element at a time, is the ultimate cure to prompt thrashing. When an output fails, the absolute worst thing you can do is delete your entire prompt and try rewriting the whole shebang from scratch in a slightly angrier tone. That just introduces more noise. Instead, diagnose the specific failure mode and then add exactly one ingredient to fix it. And keep the 3-strike rule in mind. If you find yourself tweaking and debugging the exact same prompt 3 times without success, stop, take a breath, step back, reevaluate your core mental model of what you're actually asking for, and rebuild the prompt cleanly from scratch rather than compounding your earlier errors. Treat it exactly like you're stepping through code with a debugger. The tokens, the patterns, the debugging workflows, these are all now firmly in your hands. So how are you going to build your next reliable system? Look, the difference between a frustrated casual user and an intentional power user isn't about knowing a bunch of secret magical spells. It's about respecting the token limits. It's about actively combating that lost middle problem with intentional structure. It's about stacking your patterns wisely and debugging your failures with absolute surgical precision. So the real question I want to leave you with today is this. Are you ready to stop wishing for good outputs and start actually engineering them?